our friends at Wilderness Labs just released something called Meadow.Blazor. So we can talk with IoT stuff using Blazor. And that's what we're going to take a look at in this video. Wilderness Labs has a platform called Meadow. And Meadow, it could be a chip. It can be communicating without a chip. They have a lot of really nice source code out there. They have a cloud platform as well. That is not going to be covered in this video. But they also have devices. So if we scroll down here, we see that we have the Meadow F7, which is this board here, I believe. And we're going to take a look at that in a future video as well. But they also have all of these really nice C# code that can communicate with other things. And one of the latest things that they have is Meadow.Blazor. So that means that we can use Blazor, or Blazor Server in this case, to communicate with, using their libraries, communicating with chips. And what we're going to do in this video is that we're going to take an FT232H chip and connect it to a BM680 chip. Now this sounds really hard, right? And I'm not a hardware guy, definitely not. I know Blazor, I don't know hardware. So if I can do it, so can you. So I found this circuit designer, and I really like the UI on this one. So basically they have a lot of components that I can just drag into the area here. And we need to connect 4 cables for this one. We need power, which is the red one here. We need ground, which is the black one. And then we need to connect 2 wires. And we're going to use the I2C protocol, or I believe it's called I2C protocol. It stands for Inter-Integrated Circuit, so I2C, I guess. And to do that, we need to connect 2 more wires. We need to connect the SCL, which is the clock, and the SDA, which is the data. And these are predefined on the FT232H. We connect a D0 to the clock, SCL, and a D1 to the SDA data. And that's all we need to do, because this protocol has already been decided for us. And this is the kind of nice thing with these kind of hardware, because I don't need to learn everything about it. Now, let's pop into Visual Studio and let's create a new project. So what we're going to do is we're going to select the Blazor web app. Let's just call it Meadow Blazor. That's a nice one. Let's click Next. We want .NET, well, we could do .NET 10, but let's do .NET 9. We want it to run server globally, and let's include the sample pages because that's always fun. And, well, just leave the rest. So this works with Blazor Server. And why is that? Well, we are connecting to the hardware using the USB port. So it doesn't really make sense to make a WebAssembly project out of this, because in that case, we probably want real-time communication, and in that case, we will need SignalR. So adding a layer of complexity on top of this with WebAssembly, that doesn't make much sense, since we are anyways reliant on SignalR in that case. So we're going to remove all of that and just use Blazor Server. We're going to communicate with the server, with Blazor, directly to the device and talk through the USB cable. So to get everything meadowy, we need to go up here to Extensions, Manage Extensions, and we're going to install Meadow, the VS 2022 tools for Meadow. I actually had them installed, so that's good. Now this will bring in some stuff into Visual Studio. It will bring in some templates and stuff like that. But we are honestly not going to use any of that for this demo. But it's always a good thing to have all of that installed. Next up, we're going to add a dependency. And we're going to add a dependency, add NuGet packages here, to Meadow.Blazor. And these are preview packages. So let's include that as one as well. Blazor Meadow, that's the one we want. Let's add that one. Awesome. We need 2 more packages for this. And I'm just going to bring those in here. Let's pop them in here. There we go. So what we want is we want the Meadow.Foundation, ICS, IO expanders, and we want that for FT XXXXX, because this is for the FT232H. We also want Meadow Foundation.Sensors atmospheric.BME68X, 680 in our case. So now we have all the things that we need to have this project working. Great. So let's add a new file here. This is the Meadow application. Let's add that one there. Get a little bit more real estate there. So Meadow application, great. So this Meadow application, we want it to inherit from app, and we want it to become a desktop app. All of this, we don't really need it for Blazor, for at least not for this example, but this is the recommendation because now our code is portable. So let's add that one using Meadow. There we go. We're going to override the initialize method here, and that's where we're going to hook everything up. Let's clean up this namespace as well. There we go. Okay, so the first thing we need is we need to have an FTDI expander collection, or we need to refresh that so that we know that everything that's connected to the computer, that we can find it. So we're going to FTDI expander collection devices.refresh. So now we know that we have all the devices that are connected to the computer, we have access to those. Probably we are only going to have one, so we're going to have a device called FTDI. Going to get that collection and simply get the first one that we can find. Now it's time to create that I2C bus. So let's create one, an I2C bus or I2C bus. FTD create I2C bus. I'm probably going to say I2C bus because that is what I see here. I see what you did there? Sorry about that. Okay. Now it's time to create our sensor, our BME680. So let's create a sensor, create a new one, and send in that I2C bus. And if you take a look here, we can see that we can create different channels, different bus speeds. We have the ability to actually send in some pins, and we can also specify the clock pin or the data pin if we would like to. But if we're following the conventions here with the D0 and the D1, we're good to go. So great, we have the sensor. So next up, we're going to add it to the dependency injection. But the Meadow framework has their own dependency injection. So we're going to go resolver.services, add sensor. So we're adding it to the Meadow framework's service collection. Great, so now we have all the setup code. This is going to set up everything for us. But we also need to kind of refer to the Meadow application. So let's go to program, scroll down here somewhere, and add app.useMeadow and send in that Meadow application. There we go. And another one. There we go. So now when Blazor is starting up, it's going to hook in, run this Meadow application, and get all of those things into the services. Now to be able to call these services in the Meadow application, we need another service, a service that we can inject into our pages. So let's create a new folder here. Let's call it services. And inside of that one, let's create a new file. Let's call it sensor service. Click add, fix the namespace. I'm just going to bring in a lot of code here, and we're going to take a look at all of it. Just a minute. So let's go through all of this. When we're updating our values, the values has a lot of decimals. And instead of just pushing new updates all the time to the UI, we can kind of select how often we want new values to get pushed. So I have a decimals to compare variable here. So compare one decimal, and if it differs with one decimal, then update the value. We're going to come back to that in just a bit. We have the sensor. We also have 4 values because these are the values that we get from the sensor. We got the temperature, humidity, pressure, and gas resistance. We have an event called state changed because when this is changing, we need to tell Blazor that something changed and you should also update your UI. When the constructor is running, we're going to run a task called initialize async. And we're going to come back to why this is important in just a bit. In our initialize async method, we have our sensor, and again we're using the resolver, resolver.services.get, and get me that BME 680. And if the sensor exists, then we're going to hook up updated. So when we get a new value from the sensor, and we're also going to say start updating. And we can set the interval how often we want it to update as well. Then I have a small r equal method here that compares the different values with the correct amount of decimals. Then we have the sensor updated. So the first thing it's going to do is it's going to compare our values with the values, the new values that we get from this event, and we're going to compare them with the amount of decimals we want to compare them with. And then after that, we're updating all the values because regardless if they change or not, we want to have the latest values. And then if these values changed, we want to update the UI. So one of the most performance heavy things inside of Blazor is updating the render tree. So if we don't have to go through the whole render tree figuring out what we need to send or update, that is going to be a way better solution. So in this case, we're checking has the values changed more than 1 decimal. And at the end here, we're implementing the iDispose interface. We're checking is the sensors around, stop, subscribing to the updated event, stop updating it, and dispose of the sensor. Now this was a lot of code, but this is also kind of the Blazor best practices so that we kind of get away from updating the UI once a second or how often we are getting the values from the sensor. So we kind of want to make sure that we only update the UI when we have to. Awesome, so we have our sensor. Let's pop into the pages folder up here and let's create a page to show these values. So let's create a new page. So let's go with BME680.razor. Let's remove that top thing there as well. So for this page to be accessible, we need to add the page directive. So let's add a page directive like this. And let's do a BME to start with. I'm going to show you why in a bit. So let's inject our sensor service. So inject sensor service, and let's call it sensor service. And make sure that we include that namespace there as well. Perfect. Let's override the onInitialized method. And in that one, what we want to do is we want to get the sensor service and subscribe to the state changed event. So let's implement that onSensorChanged. So we're going to have a private void onSensorChanged, and we're going to run the invoke async because we want to bring back everything to the UI thread. And the thing that we want to run is state has changed. So basically what's going to happen is when our sensor service is telling us, hey, you know what? I have some values. They have been updated. Could you please do something with that? We're telling Blazor that bring it all back to the UI thread, run state has changed, and then we're going to update. We're going to get an updated value. And we're going to do the same thing here. We're going to implement the iDisposable interface, And down here, we have that as well here. So we're going to stop listening to the state has changed. Awesome. We got one more thing that we need to do. We need to pop into our program here, and we need to add our sensor service to the dependency injection. So let's scroll up here somewhere, and let's add builder.services, add singleton sensor service. Because we don't need it to be anything else, because we have one single interface to the hardware here. So it's actually better if it's a singleton than anything else, to be honest. Now, if we take a look here in the BME 680, we're not showing anything. So what I did here was that I popped into ChatGPT and I said, you know what, I have these values. Could you please just write me a nice looking UI that shows all these values? I'm not sure if it succeeded, but I kind of liked it. So let's just copy all of that in here. Let's pop up here. There we go. I haven't gone through all of this and see if it actually needs all of these clauses and stuff like that. I might clean this up, but basically what it's doing here is that it is showing the sensor service .temperature.celsius and with 2 decimals. So we are comparing just 1 decimal, but we're showing 2 in this case. And the same thing for pressure, humidity, and gas resistance. Let's hook it up and see what happens. So here it is, the chip and the BM680 sensor. Let me just quickly show you the sensor. I'm sorry about the shaky camera here, but we got the FT232 there and also the sensor right there. So let's try this out. Let's start the project. Now, remember, we're running this on my machine. We're not deploying anything to any chip externally. We can do that. We're going to take a look at that in a later video. But right now, we're starting up our Blazor application running on my machine here. And we got a USB cable connected to the FT232H. And we can take a look here, seeing initializing OS using a default app config. We're getting the Meadow application and everything is starting up, right? And here we have our trusty application. So let's pop in here. So let's type /BME, I believe we did. And there we go. And we got some values here as well. I think that some of these values are a little bit off, but that's not the framework's fault, it's the sensors. And as you can see here down here, I also threw in the latest update. It's not going to update once per second like the default is, I believe. You can see that it is updating, and if I simply heat it up just a little bit, and you see that the values changed in the UI. So this is the way that we can use Meadow.Blazor to communicate with chips like this. But there is one thing that I noticed that you might run into. So what I'm going to do, I'm going to shut this down. I'm going to remove the home component here, and I'm going to set the BME here to the startup page. And let's pop into our sensor service here and set a breakpoint right here. So when we get our sensor back. So if I start this one up, so what is going to happen is that the Blazor site is going to start up, but it's going to be faster than the Meadow application. So we don't have any sensors here right now. So now when the page is trying to use this sensor, well, it doesn't exist because, well, it hasn't been set up yet. So we kind of get into this problem that the Meadow application is doing its thing, and we're not going to have resolvable components until it's actually done. So I came up with an idea. I'm just going to add a file to services here, and I'm just going to paste it in here. So basically what we have here is an extension method called getWithRetryAsync. So we want to retry until we have this component available to us. But we don't want to do this forever, so we also have a timeout specified here. So we are extending the Meadow service collection. We have a timeout, it's default null because we have a default value in there as well. We are waiting 100 milliseconds between retries. we have a cancellation token, and down here we are getting the actual timeout. So we're checking if the timeout is null. In that case, we're going to set it to a default of 20 seconds. Then we are retrying while the cancellation token hasn't kicked in or the timeout hasn't, well, timed out. We are trying to get the service. If the service is okay, it's not null, we're going to return it. Or if we haven't got the service, we are delaying for the amount of milliseconds, in this case 100, and then hopefully we will get that service back. So if I just save this, I'm going to pop back to our sensor service here, and instead of calling get, we're going to call get with retry async. That also means that we need to await this one, like that. Since all of this is starting up, we kind of need to wait for the Meadow application to be done to set everything up before we can access these values. And since the sensor service is a singleton in our application here, we kind of need to make sure that we wait for that to happen before we try to access the hardware. All right, so let's run this with the retry async and see what happens. So it's going to retry until it gets that value, or well, it might fail, but we're going to have by default 20 seconds to kind of get everything set up. And this is only the initial start of the application this problem can happen. And there we have it. We have it running. In an upcoming video, we're going to do all of this again, but with the Raspberry Pi. So I'm going to show you how you can get Blazor running on top of the Raspberry Pi, and also to get stuff happening there. We're going to get the LED to blink and all of that goodness. So make sure that you like, subscribe, and please share it with your community. Thank you so much, and hope to see you in the next video.